next is the clade race. And so for this one, we're essentially like with our previous lesson, we knew the history of the cars. We actually don't know the history of organisms. No one was there to write it down from almost all of evolutionary history. And so we have to say, well, how do we recreate this? Well, we look at the evidence that's left behind, and that evidence that's left behind is our characteristics, the traits that we have. And so that's what it tried to do with this analogy for the race, and kind of setting up the stamps as being like the characteristics and the runners like species here. So as I'm looking at this tree, if I'm trying to interpret what this tree is saying, right? What this is saying is that all of these species were part of the same group, and then that group split. Most of this population over here, it's what becomes most of the species that we have today. But the one that's split this way became a trout. Now, we're not showing every species here. There are so many different species of fish that we could throw in on this chart, right? We're leaving them out because maybe that's not the species that we're interested in learning about their evolutionary history. The trout continues to evolve. It didn't stop evolving just because it split off. It kept going. All these continue to evolve. And there are species that we left out of here, of course, but we just include the species that we want for answering the questions we might be studying, right? So as we look at this, we can see why we didn't include trout on this part, right? Trout didn't have these two synapomorphies that all of these have. 4 limbs and lungs were evolved, and then this common ancestor passed it on to all of its descendants. Trout didn't share that common ancestor, and so it didn't get that trait. It did share this common ancestor, so it did get the vertebral column. Trout, again, continued to evolve. They got traits on their path. They did things that helped them survive in their environment. They didn't get these things. And so that's what the tree is showing us, that branching pattern of how these populations divided at one point in time. And the evidence that we have of those divisions is the evolutionary traits, the traits that they have today, and the ones they share in common with others. And so that's how we kind of build these trees, and it's the underlying evidence. We'll go more into the evidence next week in lesson 7 about how we can kind of use a little bit more quantification, numbers in that, but that's the basis of it. So if we were to look at this and I were to say, all right, what's more closely related to a gecko? A cow or a salamander? Well, to do that, I want to find the most recent common ancestor the gecko shares with each of those. So gecko and cow, I'm going to follow back through the tree. And the last point they were part of the same population was right here. Okay, all right, mark that down, right? That's where it was. Gecko and salamander, the last time they shared a population was all the way back here. So for cow and gecko, it was here. For gecko and salamander, it's back here. Now, some people might say, well, hey, a gecko looks more like a salamander. Are you saying that cows share a more recent common ancestor with geckos? They do. And how do we know? Because they have key synapomorphies like the amniotic egg. Everything that has the amniotic egg fits in this group. And so that's why we put gecko in it. Even though they might have some superficial similarity, some similarities to salamanders, these key things are left out, right? Now, just because scales were turned to hair by cows, that's what we think happened if we look at the proteins involved, right? Hair is modified scales. They modified their scales after gecko split off. Salamander split off before that even and didn't even get these traits. All these traits that would have evolved here, salamander didn't get. And that's why we don't put salamander as being what we call sister. It's not closely related to gecko. We would think that cow and human would be more closely related to gecko, right? Now, if I were to say, okay, and so that was all based on the most recent common ancestor. More recent in time means they have more evolutionary history shared. And so we say, all right, cow and gecko are more closely related to each other because they share a more recent common ancestor than gecko and salamander. Now, if I were to say what's more closely related to gecko, cow or human, what did I do there? What's more closely to cow or human? As we look at that, we would again follow it, go back to the most recent common ancestor. So humans and geckos is there, cow and gecko, it's the same one. Well, in this case, they would be equally related. And they would be equally related because they share the same most recent common ancestor. There's no evolution that cow or human share with gecko that the other one doesn't also share. And so that means they are equally related to gecko. One last thing for this lesson. If I were to ask you what's the most advanced species on this tree, most people might say humans. They'd say humans because we dominate the world, the natural world. We kind of do, but only in some respects. We have the largest influence on other species. I'd say that's undeniable. But if we're looking at biomass, there's plants and insects that probably have more biomass than we do. So how we define it is a little bit tricky, right? Population numbers, and that's probably not the best. That wouldn't put humans at the top either. So how we define advanced would be a little bit tricky there, right? Well, which one's least advanced? The temptation would be to say trout. Well, if I were to take a trout and throw it into the middle of Deer Creek Reservoir, and I were to take a human and throw it into the middle of Deer Creek Reservoir, who's more evolved now? The trout. It's more evolved. It fits its environment better. The trout, salamander, they aren't primitive. They evolved to fit their environments in ways that are better than what a human would fit their environment. Each of these species that are, as long as they still exist, are continuing to evolve. And so it's not appropriate. It denies the way evolution works to say that one species is more evolved or advanced than another. Now you could say a trait, right? We could say, oh, scales is the ancestral trait, hair is the derived trait. It's evolved more recently. I'm okay with that. We can talk about traits that way. We don't want to talk about species that way because it leads to this mentality of that there's advanced species where everything is on the path to becoming a human someday. All right, we're never going to see like human-like lizards walking around, driving cars, things like that, right? That's not going to happen. That's not the way evolution works. Geckos are not on the path to becoming human someday. Instead, they're on the path to becoming the best fit for their environment that they can't be. And they won't branch into becoming human-like anyway. Right? We fit our environment, they fit theirs.